Hello students. So we have discussed Carnot engine and we know that the Carnot engine is an ideal engine. Okay. So what do you mean by that? In fact that is the Carnot theorem which I am going to state now, is that of all the engines, right, which are working between the same temperature difference, means of source, fixed temperature difference of source and sink, right? If there are many engines, no engine will have efficiency greater than Carnot engine. That is Carnot theorem. What it says, that of all the heat engines which are working between the fixed temperatures of source and sink, this is temperature TH and TL. If there are many engines you can imagine, no engine will have efficiency greater than the Carnot engine or a reversible engine, one and the same, which is also working between the same temperature limits, right? So this is Carnot theorem. That means of all the given engines working within the same temperature limits, Carnot engine will have highest efficiency. You also know that Carnot engine is not a reality, it's an imaginary engine, because all the four processes here are imaginary processes. But as I have explained to you, why this imagination, why conceiving of this ideal engine is practically important. Okay. Also reflect on this. Efficiency of a Carnot engine is equal to TH minus TL upon TH. Remember, efficiency of Carnot engine is of course QH minus QL upon QH, right? You can of course QH minus QL upon QH. That is of course, but that's a expression for efficiency even if the engine is not reversible. That means even if it is not Carnot engine, there also efficiency expression is heat supplied minus heat rejected, that is W net, upon heat supplied, that is QH. But if it is Carnot engine, then efficiency can also be written as TH minus TL upon TH, T suffix H minus T suffix L upon T suffix H. This expression can be used only for Carnot engine, and this expression will tell you something. What it tells you is that if you higher the numerator, look at the numerator, it is TH minus TL. If numerator is higher, that means efficiency is higher. So higher the temperature difference between source and sink, higher the temperature difference between source and sink, better or more is the efficiency of the Carnot engine. More is the efficiency of the Carnot engine, right? Now think about it. I told you that Carnot engine is an ideal engine, but it's still practically useful. Now this inference that if you have temperature between source and sink, if it is higher and higher, then efficiency will be higher and higher. And this is not valid only for Carnot engine, but it's for all real engines. So think about, so if you look at actual engines, actual heat engines, if you have higher and higher source temperature, provided that the sink temperature where the heat is rejected, that is an environmental temperature, that is more or less same, fixed, but the source temperature is higher, you will see those engines to be having high efficiency. That means more of the heat given to those engines is converted into work. So practically you can see that the heat engines which have higher efficiency at which heat is released from the source, fuel, whatever, that engine will have higher efficiency. Okay, so I want you to remember that this expression is valid only and only for Carnot engine. For Carnot engine also, expression can be also written as QH minus QL upon QH. That's also fine. But if it's Carnot engine, I mean this is efficiency as function of temperature only is applied only to Carnot engine. Carnot engine does not violate second law. So efficiency of Carnot engine can never be 100%. Now I think I am repeating this 10th time, maybe, but I know students always carry this misconception. It's an ideal engine doesn't mean it is violating second law. The beauty of Carnot engine is that it is staying within the limits of first law and second law. It's not violating that, but still it can't be constructed in reality. But it can give you practical tools for analyzing, improving the technology on the ground. Thank you.